students, we are going to start new chapter, Unit 7, P block element. And this is a very vast chapter from chemistry, and the question that you are going to get in examination is like reasoning type, okay, drawing the structure, then complete the reaction type question, and you will get questions from some preparation method like Haber's process, contact process, Ostwald process, and some questions from xenon compound and interhalogen compound. Okay, before moving to the main topic, so let us briefly discuss this P block element. Now this not P block element, periodic table. Okay, so this periodic table is divided into 4 blocks as P, D and F. So as we know that S can accommodate 2 electrons, right, maximum, so it have 2 group in it, 1, 2. P can accommodate maximum 6 electrons, it have 6 groups. From 13 to 18, D can accommodate maximum 10 electrons, so 10 groups, and F can accommodate maximum 14, so 14 groups. And F, you can see 2 series, lanthanide series and actinide series. Okay, now this D block element starts from period 4 and your F block element starts from period 6, and your D orbital, okay, it starts from 3 shell, and your F orbital starts from 4th shell. Now let us move to the next topic, that is P block element. 13 and 14 you have already done in class 11, so we are going to focus on group 15 to group 18. Okay, now P block element, so it's general electronic configuration. So P block elements, okay, it starts from group 13 to group 18, right, and general electronic configuration is Ns2 Np1 to 6. Since the last valence electron enters P subcell, so this element, okay, is what called P block element. Next, so we are going to start from group 15. Okay, now members of group 15, it's nitrogen, phosphorus, arsenic, antimony, bismuth. Okay, so nitrogen, phosphorus, arsenic, antimony and bismuth. So this nitrogen is period 2, 3rd, 4th, 5th and 6th. So we'll try to write down the general electronic configuration for all these members. Okay, group 15 is also called your nitrogen family, member of group 15. So valence electronic configuration of nitrogen is 2s2, okay, 2p6. So your period represent valence shell, right? So P, it is your 3s2, 3p6. Now D block start from 4th group, right? So 3d10, then 4s2, 4p6. 5th, 4d10, valence is your 5, so 5s2, 5p, it's not 6, okay, it's 3, I'm so sorry, 3, 3, 3, 3, okay. And your F block element starts from group 6, right, period 6, so 4f, 14, then 5d10, 4, then 5d10, then valence is your 6, 6s2 and 6p3. Okay, so this is the electronic configuration, valence electronic configuration for the members of group 15. So what is the general electronic configuration for group 15? It is your Ns2 Np3. So what is the valence electron here? 5. So group 15. Okay. Now next let us discuss the occurrence of this element in nature. Okay. This nitrogen occupies 78% by volume of Earth atmosphere. Okay. As nitrogen gas. Okay. Then So this is your 33rd abundant nitrogen, again nitrogen, abundant element on earth crust. Then your phosphorus. Okay, so phosphorus is 11th most element, okay, on earth crust. So this is again present in bones, right, living tissues, cells, nucleic acid, ATP, ADP, isn't it? The arsenic, the abundance of your arsenic, antimony, bismuth is very low, okay. So this is all about its abundance. Now let us discuss atomic and physical properties of group 15 element. So first we'll start with atomic and ionic radius. Now what will happen to the atomic radius, ionic radius on moving down the group? Yes, it increases, right? Why? Because of additions of new cells, right? Due to addition, again, so now we are going to discuss atomic and physical properties of group 15 elements. So first we'll start with atomic and ionic radius. Now what will happen to the atomic radius and ionic radius of element down the group? It increases. Why? Because of additions of your new shell in succeeding element, isn't it? So nitrogen, it belongs to group 2, so it will have 2 shell. Then phosphorus, third, so it will have 3 shell. Then arsenic, it will have 4 shell, isn't it? So this is how the size increases on moving down the group, both your atomic and ionic. Now next is ionization enthalpy. What will happen again to the ionization, first ionization enthalpy on moving down the group? Yes, it decreases. Why? Because of increase in the atomic size of an atom. Now with increase in atomic size of an atom, what will happen? The attraction between your nucleus and your valence electron, what will happen? It decreases, right? Because your electron, with the increase in atomic size, your valence electron will move farther away from the nucleus. Then the attraction between the two, it decreases and it becomes very easy to remove the valence electron. So for this reason only, what will happen to the ionization enthalpy on moving down the group? It decreases, right? Now next is electronegativity. So what will happen to the electronegativity? Electronegativity, this is your tendency to pull electron toward itself, right? So what will happen to the electronegativity? So it decreases down the group, decreases down the group. Why? Again, because of increase in the atomic size. Okay. Now next, oxidation number, okay, oxidation state. Now group 15 element show the oxidation number from -3 to +5, okay. So common oxidation state shown by nitrogen. So nitrogen show all your oxidation state from -3 to +5, okay, whereas your phosphorus show -3 oxidation state, +1 oxidation state, +4 oxidation state, +5 oxidation state, okay. +5 oxidation state, the stability of it will decrease down the group, whereas your +3 oxidation states stability increases down the group. Reason is because of inert pair effect, okay. In order to show +5 oxidation state, so all the electrons in this subcell, okay, in this orbital, it should able to take part in bond formation. Now it will take part in bond formation only when the electron becomes unpaired. So here S, right? So we know, so it contain unpaired, one paired electron and 3 unpaired electron. Now when how it show plus 5 oxidation state, it will show plus 5 oxidation state when one of the electron will jump to your d orbital and will get unpaired, and you will get 5 unpaired electron. Okay, so because of this reason your element is showing plus 5 oxidation state. Okay, but here on moving down the group, what happen is this paired electron, okay, will not urge to get unpaired. It will to unpair this electron, okay, large amount of energy is required, so it remain paired. So that means what? Your s electron will not involve in the bond formation. So because of that, okay, plus 5 oxidation state, its stability decreases down the group, whereas plus 3 oxidation states stability increases down the group. So this the property by which your s electron wants to remain in the paired state, or it won't want to get like unpaired state, right? So this is what called inert pair effect. Next is your tendency to show, okay, -3 oxidation state. Decreases down the group, okay. So why -3? After gaining 3 electrons, so it will acquire 3 electron, right, and it will have oxidation state -3. Now this tendency decreases down the group. Why? Because what will happen down the group? Atomic size increases, right? Atomic size increase huncha. So यसले के गर्नु पर्यो? -3 कसरी हुन्छ भने when it gains electron. So tendency of gaining electron जति ज्यादा हुन्छ, okay? Here -3 oxidation state show गर्ने tendency त्यति नै ज्यादा हुन्छ. But what we have studied is your electronegativity, okay, which is your electron pulling tendency decreases down the group. So because of that, so it will the tendency to show -3 oxidation state down the group decreases. Okay, now all the oxidation states of nitrogen, okay, from +1 to +4 tend to disproportionate in acid solution. So what is now disproportionation? So it's a reaction where same element get oxidized, right, or reduced. So example for this is like nitrous acid, okay. So this will disproportionate to give nitric acid, water and nitric oxide, okay. Now what is the oxidation state of nitrogen out here? It is +3. And what is the oxidation state out here? +5 and +2. Now what is happening to the oxidation state from nitrous to nitric? Increasing, right? So oxidation is taking place, isn't it? So and from +3 to +2, what is happening to the oxidation number? It decreases, so that means reduction is taking place. So all the oxidation state of nitrogen from +3, okay, to +4 will disproportionate as given in the question. So now next we are going to discuss metallic property, okay, of group 15 elements. Now what is metallic property? Okay, or metallic, it measures, right, the tendency to lose electron. So the more it loses electron, okay, the more it become metallic in nature. Now as we have already discussed, right, what will happen to the ionization enthalpy? Ionization enthalpy, so that means the tendency to lose electron. Tendency to lose electron, right, it also increases down the group. So what will happen to the metallic property then? Metallic property, okay, it also increases down the group, okay. So nitrogen, phosphorus, these two are non-metals. then arsenic and antimony. These are metalloids, okay, and bismuth, this is your typical metal. Understood? Now next, okay, next we are going to discuss chemical properties of group 15 element or nitrogen family. Okay, so we have already studied in class 11 that period 2 element will show anomalous behavior, right, or show different properties with respect to the remaining elements, isn't it? So this is what called anomalous property, and what is the reason? What are the reason for anomalous property of group period 2 elements or yes nitrogen? Because of small size, right? Then high ionization enthalpy, then high electronegativity and absence of d orbital, isn't it? So your d orbital starts from third shell only, right? So because of this reason, okay, your nitrogen show different properties. First anomalous behavior is nitrogen exists as diatomic molecule. Okay. Now the reason is, so only nitrogen have the tendency, okay, to form p-pi multiple bond. So because of its small size, high electronegativity, so therefore, so nitrogen will exist as molecule, okay, diatomic molecule, where there will be a triple bond between nitrogen and nitrogen. So multiple bond because of tendency to form p-pi bond. Okay, so त्यसले गर्दा ट्रिपल बन्डमा दुईटा नाइट्रोजन मात्र बस्न सक्छ. So nitrogen exists as diatomic. The next question is, catenation tendency of nitrogen is lower than rest member. Again, catenation means unique property, right, to link itself with atom of same element or atom of some other element. So that means it should able to form an single bond, right, or p single bond. Then only, so it will able to link, okay, with each other and form a long chain. But here this N bond is very weak, okay, whereas phosphorus bond is strong. Now because of this weaker N bond, so its catenation tendency is lesser than the rest member, where rest member, so this bond arsenic bond, so this single bond is very strong. Okay, so for that reason they can link together to form a long chain. Now third point is, nitrogen cannot form p-pi d-pi bond. Why? Very simple. The answer is, it will not have, right, because of absence of d orbital. So since it do not contain d orbital, so possibility of forming p-pi and d-pi orbital is minimum. There's no possibility of forming p-pi d-pi bond, isn't it? So for that reason, nitrogen cannot form p-pi d-pi bond, whereas rest member, phosphorus, arsenic, antimony, all can form p-pi d-pi bond. So these all are the anomalous behavior of nitrogen. That's all for today. So see you in next video. Thank you.